So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic speed and velocity. So guys, in short, stay till the end of this video. So let's go ahead and start with the first question here. It says, the slope of linear distance time graph represents A, velocity, B, speed, C, displacement, D, acceleration. So guys, the answer to this question is option B here, and that's speed. So the slope of a linear distance time graph represents speed. And that's it for this question. Let's go ahead and consider the next question, guys. Alright, so the next question here is question number 2. It says, during the same time interval, it is observed that a train travels the same distance as does a lorry. The two vehicles therefore have the same A, uniform acceleration, B, average speed, C, average velocity, D, instantaneous velocity. So guys, the answer to this question is option B here. If they travel the same distance, so they have the same average speed. So that's it for this question, and let's consider the next question, guys. The next question here is question number 3. It says, the time rate of change of displacement is known as A, speed, B, impulse, C, velocity, D, acceleration. So guys, the answer to this question is option C here, that's velocity. So let's note that velocity is change in displacement with time, whereas speed is change in distance with time. So that's it for this question. Velocity is the time rate of change of displacement, and option C is the answer to this question. So let's go ahead and consider the next question, guys. So here's the next question, question number 4. It says, a boy cycles continuously through a distance of 1 kilometer in 5 minutes. Calculate his average speed. Alright, so guys, the guy cycles continuously through a distance of 1 kilometer in 5 minutes. So in order for us to calculate this, so 1 kilometer is actually 1000 meters, and then 5 minutes is actually 5 times 60, so that's 300 seconds. So in that case, that will be 1000 kilometers over 300 seconds. So when we divide this, we'll have 3.3 meters per second. And that's option C here, guys, 3.3 meters per second. So that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 5. It says, a bird flies at 10 meters per second for 3 seconds, 50 meters per second for 3 seconds, and 20 meters per second for 4 seconds. Calculate the bird's average speed. Alright, so guys, the average speed of this bird will be the total distance covered over the total time here. The distance covered in the first flight is 10 times 3. That's the speed here times the time. That's 30 meters. Then the distance covered in the second flight is 15 times 3. So that's 45 meters. And then the distance covered in the third flight is 20 times 4. So that's 80. So that's 80 meters. So if we add up the distances traveled and divide by the sum of the time taken, that will give us the average speed. So let's go ahead and add 30 plus 45 plus 80. So that will give us 155. So 155 over 3 plus 3 plus 4, that's 6 plus 4, that's 10. So 155 over 10 is 15.5. So guys, the average speed here is 15.5 meters per second, and that's it for this question. Let's go ahead and consider the next question, guys. The next question we have here is question number 6. It says, the diagram above shows the speed time graph of a car. If the car covered a total distance of 600 meters in 25 seconds, calculate the maximum speed. Alright, so guys, for this question here, considering the diagram we have here, we see the car moving in different time intervals here from 0 to 5 seconds, from 5 seconds to 20 seconds, and then from 20 seconds to 25 seconds. So guys, the total distance covered here is 600 meters. So we're going to have that 600 meters is actually half times the time here times Vmax. So guys, looking at this graph here, it takes 5 seconds here for the first movement here. So you see at this point you have 0 to 5 seconds, and that's 0 to 5, that's 5 minus 0, that's 5. So you have half times 5 times the Vmax, then plus, you see the second time interval here, that's from 5 to 20. So you can have 20 minus 5 is 15. So that's plus 15 times Vmax. So we're going to add that to the last speed here. So that's the speed here between 20 to 25. So we have half of 20, 25 minus 20, that's 5. So half of 5 times Vmax. So when we add all these, we're going to have that half of 5 times Vmax is actually 2.5 Vmax, then plus 15 times Vmax, then plus half of 5 times Vmax, that's 2.5 times Vmax. So you have 2.5 times Vmax plus 15 Vmax plus 2.5 times Vmax. So that will be equal to 20 Vmax. So it means that 600 is equal to 20 Vmax. So Vmax is going to be 600 over 20. And guys, that will give us 30 meters per second. That's option C here. So let's go ahead and consider the next question. So guys, the next question we have here is question number 7. It says, uniform speed occurs when there is equal change of A, distance in equal time, B, displacement in equal time, C, velocity in equal times, and D, acceleration in equal time. So guys, the answer to this question is option A, distance in equal time. So uniform speed occurs when there is equal change of distance in equal times. So that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 8. It says, the diagram above illustrates a velocity time graph. Determine the distance between x and y. Alright, so guys, the distance between x and y here, for us to determine, you know that the distance will be the area under a velocity time graph. So the area of this portion, x to y, is the area of a rectangle. So we are going to have the length here to be from 0 to 40 on the y-axis, that's 40. So whereas for the breadth here, we're going to have from 4 to 8, that's 8 minus 4, that's 4. So 40 times 4 is 160 meters here. So guys, the distance here is 160 meters, and that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 9. It says, the speed of an object in rectilinear motion can be determined from the A, area on the velocity time graph, B, slope of a velocity time graph, C, slope of a distance time graph, D, area under a distance time graph. So guys, the answer to this question is option C, slope of a distance time graph. And that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 10. It says, the average speed of an object is determined by dividing the sum of its initial and final speeds by 2 only when the acceleration is A. changing, B. decreasing, C. uniform, D. increasing. So guys, the answer to this question is option C here, uniform. So when you have a uniform acceleration, the average speed of an object can be determined by dividing the sum of its initial and final speeds by 2. So that's it for this question, and this is where we end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll be sure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. You can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.